Question: limit x tending to 0, x to the power of x. This is nothing but 0 to the power of 0. So do one thing, fx to the power of gx. Now you write like this: limit, you write this as log x to the power of x, because a can be written as e to the power of log a. This is that a. This is that a. Now drop all this. Now the thing is, wait a minute. Yes, you can write directly e limit x to the power of 0 is log x to the power of x. This is same as e to the power of limit x to the power of 0 x log x. Now this is of the form 0 into infinity on the top. So now this is equal to, you see, now do one thing, e limit x to the power of 0 log x upon 1 by x. Now this is of the form infinity by infinity form. Sorry, infinity by infinity. This is infinity by infinity form. Now use L'Hospital's rule. E limit x tending to 0 1 upon x minus 1 upon x square. This is equal to e limit x tending to 0, take the minus out, x square upon x, cut this x, take the limit, this becomes e to the power of 0, and the answer is 1. Now let's do it again. Let's do another one. Now see, now question, limit x tends to pi by 2 sin x to the power of tan x. Now this is of the form 1 to the power of infinity, because sin pi by 2 is 1, sin pi by 2 is 1, and tan pi by 2 is infinity. This is 1 to the power of infinity. So do one thing, straight away use this formula, e limit x tending to pi by 2 tan x sin x minus 1. Write tan x as e to the power of limit x pi by 2, write sin x minus 1 upon cos x. Now write this as e limit x pi by 2 sin square x minus sin x upon cos x. Now if you see this is nothing but 0 by 0 form. This is 0 by 0 form. So using L'Hospital's rule, e limit x pi by 2 sin x cos x minus cos x upon minus sin x. Now take the limit pi by 2. This will be e to the power of, take the limit pi by 2, take pi by 2, here it will be 0, 0, and then this will be 1. This will be minus 2 by 1. That is nothing but e minus 2. E minus 2. Now, another question. Question is, limit x tending to a 2x minus a to the power of tan by x by 2a. Now see one thing, this is fx and this is gx. This whole is gx, this whole is fx. Now fx, see I told you fx minus 1 tends to 0. That means fx tends to 1 and gx tends to infinity as x tends to a. I told you this concept in my earlier video. Now this, as this goes to 1, this goes to 1. So this is nothing but 1 to the power of infinity form. This is 1 to the power of infinity form. So use this now. E to the power of limit x minus a x tending to a fx minus 1 gx tan pi, let me rub this now, tan pi x by 2a. Now This will be E limit x tending to a. This will be 1 minus x by a tan pi by x by 2a. Now very simple. This is, if you take the limit, it will be 0 into infinity. So do one thing. Write this as E limit x tending to a 1 minus x by a. Take tan. This tan is here, isn't it? Tan you can write 1 upon tan. This can be written as 1 upon tan. This is all in the power of E actually. Whatever I am doing, it is in the power of E. It's in the power of E only. So this is 1 upon tan pi x by 2a. Now this is nothing but e to the power of limit x tending to a 1 minus x by a upon cot pi by 2ax. Now this is nothing but 0 by 0 form. This is nothing but 0 by 0 form. So now you will use L'Hopital rule on this. E equal to limit x tending to a, differentiate this to minus 1 upon a, and this become cot is minus cosec square pi by 2a x into chain rule pi by 2a. Now see, this is e to the power of, now when you have taken the now you take the limit. Now if you take the limit, this minus and this minus will cancel out. You will have 1 upon a, this is cosec, this will go on the top as sine square pi x pi a, it will be a pi a by 2a and then whole divided by pi by 2a. Now see, this is nothing but a cancels pi by 2, sine pi by 2 is 1, this whole thing becomes 1. So e 1 by a into 2a by pi. So a cancels, you get e to the power of 2 by pi. This is your answer. Now if you see, let us do some more questions on this type. You can see this one, question limit x tending to 0, a to the power of x plus b to the power of x by 2 whole to the power of 1 upon x. This is of the form 1 to the power of infinity as x tends to 0. Put x 0, a to the power of x, a to the power of 0, b to the power of 0 is 1. So this is 2 by 2 is 1 to the power of infinity. So you take e to the power of limit x tending to 0, a to the power of x, b to the power of x by 2 minus 1 into fx into 1 upon x. Now do one thing. See this. E to the power of limit x tending to 0, a to the power of x plus b to the power of x minus 2 upon 2x. Now see one thing. 2x. Now this is nothing but 0 by 0 form. Even you could do it in another method also. I'll tell you later on. Wait. This can be done in another method. This solving this. Now e limit, you want to do this way, x tending to 0, a to the power of x log a to the power of x log a plus b to the power of x log b upon 2. Now taking the limits, it is log, half log, it is log a plus log b. It is log a plus log b. That is nothing but this is nothing but e to the power of half log ab by the formula of log a plus b. This is nothing but e to the power of log ab to the power of half. Now this log and e goes off. This is ab to the power of half. I was telling you, you can do it in another form. That is this much part. I am talking only about this much part. I'm talking only about this much part. See, e to the power of limit x tending to 0, a to the power of x minus 1 plus b to the power of x minus 1 upon x, and then you take this 2 out, half out. This is actually what I have done. This is actually nothing but e to the power of limit x tending to 0, a to the power of x plus b to the power of x minus 2 upon 2x. If you again do take the LCM and join everything, LCM लेके सब join करोगे तो वापस ये मिल जाएगा. Now this is nothing but, look, e to the power of half limit x tending to 0, a to the power of x minus 1 upon x, this limit plus limit x tending to 0, b to the power of x minus 1 upon x. This is the formula only of limits. This is half log a plus half the log b. This is a formula of limit only. This is same as again e to the power of the way I did it. E to the power of log ab to the power of half, which is nothing but ab to the power of half. This was I was trying to show. That's your wish. If they ask by your hospital, do in the above method, or you can do it in this method also if you have choice. That's your choice. This is a different, I just showed you another approach to that. Now, instead of using the L'Hopital's rule, you can do it this way also. But actually, it is the L'Hopital rule only which works here. But, if you know the value of limit, what is this limit? What is this limit? If you know it, otherwise you do it that way only. Now another question is like this. Question is, say, limit x tending to 0, sin x upon x whole to the power of 1 upon x. Now this is that fx. This is 1 to the power of infinity in the limit. So write limit e to the power of. So you write e to the power of limit x tending to 0, sin x upon x minus 1 into 1 upon x. Now e to the power of limit x tending to 0, sin x minus x upon x square, and this is nothing but 0 by 0 form. Now e to the power of limit x tending to 0, cos 1 minus 2x. Now you put the value 0, again it is 0 by 0 form. Again you differentiate. Again you use, I use the L'Hopital rule, I forgot to tell that. But whenever I am telling to differentiate, right now I am talking about L'Hopital rule only. Sin x upon 2. Now put the value of the limit. This will be e to the power of 0 by 2. Nothing but e to the power of 0, and this is nothing but 1. That is the point. It is nothing but 1. Yes, this is nothing but 1. Now see one thing. Let us do one more question like this. Something little better. You can see. What I do is this. Look here. What I do is this. Very simple. Question. Limit x cube plus x square minus 2x upon x square plus x. This you can take out by, you can do it by taking factors, the way I did in the chapter of limit. Also you can do it in the form of L'Hopital rule, 0 form. This is the question, sorry. Wait a minute. This is the question. Yes. Now take use L'Hopital rule. This is 3x square plus 2x minus 2 upon 2x plus 1. Now if you put 0 by 0 form, put 0, this will give you minus 2. This will give you yes, minus 2x. So this will give you yes, this will give you minus 2 and 1. The answer is minus 2.